Hello and welcome to Group Brandywine. My name is Joseph McDonald,
I'm Andrew Fursov.
Maria Athanasiou.
and this is our fluids project. The system we chose is an aquaculture tank, which is used for fish farming and has the benefits of controlling the environment the fish are raised in, allowing for more fish to be raised in a smaller volume.
So how does this system work? So this kind of system works by pumping the clean water into the fish rearing tank. Then wastewater is pumped into the solids removal tank, which is then filtered and collected into the sump. From there, the water flows back into the fish tank and the cycle continues just like it is shown in the diagram below.
So many control volumes within an aquaculture farm can be analyzed with respect to fluid dynamics. Tank walls and bends in pipes experience forces, while energy and momentum of fluids can be calculated within pipes.
Here, the plane surface is a small square along the round wall of the bottom of the tank, and the curved surface is the cross-section of a quarter cylinder, which represents the fish, which is submerged in the tank. We assume the diameter of the fish should be 0.1 meters, and the horizontal projection is in pink and the vertical projection is in blue. To solve for the hydrostatic force, we use the first formula on the right, which is F equals rho GH times A. And then to get the vertical distance to the center of pressure, we use the second formula on the right. And lastly, calculated the horizontal and vertical projections or components to get the magnitude of the resultant hydrostatic force on the curved surface and the angle of action.
Next thing we had to do was to consider where steady flow is occurring in our system in order to apply the continuity equation. To find the mass and volumetric flow rates, we had to make a few assumptions, starting with the control volume, which is displayed inside the dashed yellow lines, showing the pipe through which water flows into the system and the pipe in which it flows out of it. We have their diameters, and through research, we found the velocity of the water coming into the system. Using all of our givens, we can solve the outgoing velocity for the outgoing velocity and then plug that into the respective formulas to find the mass flow rate and volumetric flow rate. After that, we can apply the work energy equation, and to do that, we need to identify our new control volume and decide on the 2 points that we'll use in our equation. We know the useful head and the velocity at point 2. Our equation can be further simplified now because the pressure and velocity at point 1 can be canceled out as the datum is at the surface of a large reservoir. Height values at point 1 and 2 can be canceled out because there is no difference in height between those 2 points. And value of energy extracted by a turbine and value of energy lost can be canceled out because there is no turbine in the system and we are ignoring losses due to friction, heat, etc. This leaves us with a much simplified equation from which we can find out the pressure at point 2. Solving, we found the pressure to be 20.14 megapascals.
So in applying the impulse momentum equation to find the resultant force on a 90-degree bend in the pipe, the assumed values included in and out velocities from the previous calculations, cross-sectional area of the pipe, pressure at point 2, and the difference in height between points 1 and 2. The difference in the mass flow rate was found to be 0 as velocities and areas at point 1 and 2 are equal. Pressure at point 1 was found using the work energy equation, as you can see in the second equation. Finally, the resultant force was calculated by summing the pressure forces and force due to water flow in the third line and taking the norm of the sums for each direction in the final equation. As for ways the system could be better understood or optimized through this kind of modeling, say a specific velocity is required for the fish to maintain a healthy environment. This type of modeling can be used to determine the required pipe diameters, horsepower for the pumps, pipe heights, etc., to make sure such a velocity can be reached efficiently. And these are our references. Thank you for listening.